Did anybody want to ask about anything on page 57?
All of them.
11.
Wow.
All of them.
All right. Now, the next thing, since everybody wants to see something, is obviously number 10, A, B, C, and D are exactly the same question.
Yeah.
So if you can do one of them, you can do all of them. So I'm willing to show one of them.
Okay.
D? Sure. So D, I'm going to redraw it because that's a little hard for you people to see.
Even is.
Yeah? And I want the angle of inclination. Where is every single angle of inclination?
Up.
It is between what?
Oh. Right. The lengths.
Between the horizontal and up. So where is the horizontal line here? 1.1 or 8.2? The horizontal line. 1.1. So, and then up is that way, yes? So here is theta. Theta is unknown, so it's x. 8.2 is opposite. Adjacent is 1.1. Since I need an angle, it is shift tan or tan? Shift tan. Shift tan of opposite, 8.2, divided by adjacent, 1.1.
Bracket. Okay.
Close the brackets, hit equals. And then when you do that, if your calculator is in the right mode, you will get 82.4. 82.4. Everyone is good, yes? Excellent. If your calculator did not say 82.4 and you wrote all this out, what does that mean for your calculator? It is in the wrong mode, or you do not know how to punch this in.
Oh my God.
Which of those things is difficult to fix? Neither of them. Because you would come to me or one of your friends and they would show you the buttons to push. Or you would go back in your notes to where I told you to write out the buttons you push. But a great many of you didn't bother to write it out because I asked you to write it out, so you didn't. What I should have said was, don't, whatever you do, ever do D. Because as soon as I tell you not to do it, you're going to do the opposite of what I say, and then maybe you would have written it down. Of course you wouldn't have. I'm joking. That was 10. 11. Now, Austin, you particularly asked about 11. If you read the question, it explains it. I rise 20 feet in altitude, which is up 20. For every 100, I move horizontally. So isn't that an opposite of 20 over an adjacent of 100? And isn't everything over 100 a percentage? Sure it is. So 20% is 20 over 100. That's my bracket, or my decimal, yes? So all I need to do is find the angle. It's the exact same as 10. 20 over 100, but I need an angle, so it is shift tan. And that will give that angle. When it's 25, what changes? 25%. Does 100 ever change in percent? No. So what's changed?
The 20.
25. So now this is 25 over 100, and I shift tan. What's this one?
So you want the shift tan answer to all of those?
Yes.
Okay.
10 over 100. What's this one? 15 over 100. Okay? Okay. Number 14. Before you do trig, in all of my million examples, what did you have? To do trig, what did you have in all your notes? Starts with a T, ends with an E, has triangle in the middle of it. You need a triangle. Is there a triangle in number 14?
Yes.
No, there isn't. There's a picture of an eagle. Where is that eagle? At the top of a 20-meter tree. I put the eagle there on purpose so you could do this. He's on the top of a tree. There's the tree. How tall is it?
20 meters.
20 meters. A bird watcher is lying on the ground 50 meters from the tree. Where's the ground?
On the ground.
At the bottom of the damn tree. It's not floating in the air.
Okay.
There's the ground. How far away is the bird watcher?
50 meters.
Wait, I have to draw it.
That is a big eagle.
That's why the bird watcher is so interested.
Okay, yeah.
Yeah.
Makes sense. I like being interested too.
What is that?
That's the bird watcher lying on the ground holding the binoculars.
Okay.
How far away is the bird watcher?
50 meters.
50 meters.
Sorry, 50 meters.
What does that make?
Hypotenuse.
A right angle triangle with what? A theta, an opposite, an adjacent, which allows me to do trig.
The answer is
Tan, shift tan, because I need an angle, of what? 20 over 50. Easy peasy, lemon squeezy.
yeah.
Now, 19 was actually hard. I need this angle, correct? It's a little hard to see. I'm going to zoom in on it. I need this angle, correct? Everyone agree?
Yeah.
Okay. How big is that angle? From there to there.
11.1.
No. 180. It's half a circle. Yes?
Okay.
Everybody cool?
Sure.
Which means
Back corner's fine.
this angle must be 180 minus
Whoa.
that blue angle, isn't it?
Yeah.
Does everyone agree? Now, ladies and gentlemen, I know I didn't show you this, but if I told you that you had $180 and you spent some of it, how would you know how much you had left over?
You would look at it.
You would do subtraction. Do I really need, should I have needed to show you this? Are you all aware that half a circle is 180 degrees? Of course you are. Are you all aware that this red angle did not go all the way to 180? So are you all aware that by using the second simplest math you know, you can figure that out? Because if you know this number, you know the red angle, don't you? Because it is 180 minus that blue. Right? Is it possible for me to show you every single situation in the entire universe where you would need to subtract? No. So what is my job? To explain subtraction. What is your job? To apply it in a situation. Right? Everyone agree? Okay. So now the problem becomes, okay, it's 180 minus the blue angle, yes? Right?
Which is what?
And some of you will say, well, Mr. Myers, I don't know the blue angle. But you do. Because what is that? So what is that?
11.
11. What is that?
7.5.
So what is that?
7.5.
7.5. So that is blue theta, isn't it? How do I find blue theta?
Do tan shift.
Shift tan of what?
Tan. And then 7.5.
7.5 over 11, which is going to give me an angle, isn't it?
Yeah.
Well, the angle I need is 180 minus
Whatever that is.
that theta. Now, honestly, ladies and gentlemen, I personally don't find that to be a big stretch,
Wait, so what?
math-wise. Now that you've seen it, is it? It's not a big stretch, is it? It makes perfect sense, doesn't it? What's the only way you could have done this? If you really understand that the triangle can turn, then it's not a problem, is it?
How would we know to subtract the 180 though? If we
Well,
want to
again,
subtract
Ariana, that's not something I ever should have had to teach you. Let's pretend that you have $180. Okay? I steal some money from you. How much money did I steal?
I don't know.
Yes, you do. You have 108. You walked out of your house with $180 in your pocket, and I picked your pocket and stole some money. How do you know how much money I stole? Subtraction. Okay. I have 180 degrees to play with. I have lost some of those degrees.
Okay.
How do I tell what's left over? Subtraction. It's got nothing to do with degrees. It's got nothing to do with trig. It's got to do with understanding you have a certain amount and some of that is missing. That is subtraction. Right?
So a circle, okay.
Okay? Everybody cool? All right. Now, I assume some people also need to see 20. 20 is difficult. Because of what reason? There's no numbers. But what do you need to do a trig question? A triangle. In this case, the triangle is the floor, the wall, and what? The ladder. Floor, wall, ladder. Yes? Excellent. Reading the question, the wall, the distance between the base and the wall, where is that? Is that blue or is it yellow?
Blue.
It is blue. So this distance is no greater than 1/4 the length of the ladder. Does the length of the ladder matter? No, as long as this is 1/4 of it. So what number could you put for the ladder? Anything. Couldn't you, Jeremy?
25.
The ladder is one. The blue is 0.25.
That is one way you could do it.
Is the answer.
You're absolutely right. That is one way you could do it. You could use 1,
Or you can do
1, and 0.25.
or you can
Because
do one.
I was just going to get there. Everybody understands? 1, and that's 1/4 of 1. Then Jer said, well, Myers, couldn't you have made the ladder 4 meters? Which would make this what? 1. What if you made the ladder 12 meters? What would this be? 3. 1/4. What if you made the ladder 40 meters? 10. Does it matter? No. So, choose a number. Say a number. Somebody say a number.
16.
Nobody be a wise ass. Say a number.
16.
16. If that is 16, this can be 1/4 of that. So what is it?
4.
4. Now, what is the greatest angle of inclination? Where is every angle of inclination?
In between the horizontal and the up.
Right there, yes? So there's your theta.
16 over 4.
Tan shift
tan.
of 16 over 4.
And it could have been any number we want.
8 over 2. 10 over 2.5. 1,000 over 250. 960 over 215.
Wait.
It wouldn't matter. Why? Angle doesn't change no matter how long the legs are. Have I said that a few times? Have we proved that with a drawing? Should any of you be confused by that? No. Everybody cool? Cool in the gang. All right. Take a mental health moment. Shake out your sillies. Talk to your neighbors. After you turn to page 54. 56. We got to finish what happened on 56. So take a moment. Chill out. Get your thoughts together. Talk to your neighbor for a moment now so when I'm actually teaching, you can be quiet and pay attention. Okay? Okay. Gio, I hear you scored a touchdown yesterday. Running? Receiving?
No, they were in the end zone. They fumbled it and they dropped
Ah, so a safety touchdown.
it. Yeah.
Still counts. Nice.
Interception for like 25 yards.
Nice.
My brain just shut off.
All right. We are back. We are back. You can stay there, Gio. You just bring your notes. We are back. We are back. 4 times. Maybe the 5th one will work. We are back. Nope. Let's try 6. We are back. Nope. Let's try 7. We are back. Still 7. No. We are back. 8 tries. Not bad. Everybody on page 56, please draw a line in the middle, because there are 2 concepts that we are going to discuss today that are related very closely, but I need 2 separate diagrams to do it. Okay? We already talked about angles in the real world, angles of elevation and depression, or inclination and declination. But we also use degrees to measure directions. Yes? All of you who have played Call of Duty know that when you click on the scope to try and get the kill shot, a bunch of numbers come up above the scope. And as you move, those numbers change. Those numbers are degrees. From what to what? I'm going this way. I'm doing the kill shot on Gio. Bang, I got him. Now I do a kill shot on Austin. Bang, I got him. Then I do a kill shot on Josh. Bang, I got him. And I realize that, wow, killing people is fun. It should be entertainment. 0 to 180? Nobody could be behind me? 360. Because there might be bad guys behind me that I might need to get. Yes? So right now, where I am sitting right now, looking right at Moret, if I turn to Gio, I have turned 90 degrees. Yes? Everybody with me? 90 degrees to my left. Yes? Is everybody cool? Jer. Okay, guys, that wasn't the point. Can you just hold on to thinking about math for 5 damn seconds? Okay? Because if you want, I don't need to do the fun stuff. I can just sit up here and go, angles are directions. And I don't need to do that stuff to put it into your lexicon. All right? Jer.
So, wouldn't that mean that one of the 2 numbers is whether you're looking up or down, so it goes from 180 to 90 to 0 to negative 90, and then there's 360 where it's the 0,
Which is
180,
yes.
back to 0.
Absolutely correct. The up and down are angles of elevation and declination, and you can't go past straight up or straight down.
Yeah.
And the other one is the horizontal. Everybody cool? Everybody understands there's 360 of them, yes? Okay. So, that's the example. Now, in reality, hey, Mr. Como, directions, how many directions are there? Jer.
North, south, east, west, forward, back.
North, east, south, west.
And
Everybody
then up
cool?
and down, which are-
Right? Everybody good? Now, these are arbitrary, aren't they? North is not up, right? We have decided that north is up on a piece of paper just for convenience sake, right? Like the people in Australia are not standing upside down, right? They're just not. What is interesting is if you take a picture of the world and I draw it,
Thought we were drawing on that side yet.
you're not. This is for me.
Ooh, South America. Oh, wait.
You're all aware that that is North and South America, yes? What blows people's minds is if we do this to it. What's that? It's course it's the exact same thing. Where's British Columbia?
I don't know.
Where's BC?
Down there.
Describe it.
Now it would be on like the south, more on the south side of the hemisphere.
On the right or the left?
On closer to the.
Bottom left, right.
Bottom left. Here is British Columbia.
What? What?
Yeah, wait, no, other side.
Oh, wait, no, but it wouldn't go all the way to the top, would it? What? But like,
This is the west coast. That's Florida, right?
yeah, but like,
That's the Hudson's Bay, yes?
what about none of it and all that?
I didn't draw none of it. It's an example. The point I'm trying to make is northeast, south, and west are arbitrary, aren't they? We chose them. Okay? But we all agree on them because everybody knows where north, south, east, and west are, right? If I tell you I'm going to move 5 steps to the right, what direction am I moving?
That's a good question.
What direction am I moving? I'm going to move to the right. Point where I'm going.
Because
But
you're right.
Joseph, doesn't the L make left?
Yeah.
And isn't that way left?
It's
But
left
that's
for me,
your
right
right.
for you.
Right. So left and right makes no sense, does it?
Yeah.
So we need north and south and east and west. Now, if I tell you I'm going to move 5 steps to the north, is that the same for both of you?
Yeah.
Where is north?
We don't know.
You have no idea, do you? Some of you do. Where's north? That way. So if I'm going to move 5 steps to the north, I'm going that way, yes? And that's the same for everybody. It's not, well, your north or my north. It's just north. Everybody cool?
Yeah.
Okay, good. Now, we're aware that this compass has 360 degrees, yes? Because it makes a circle, right? So we have arbitrarily decided north is 0 degrees. Now you should be writing. And we move this direction. So how many degrees is not... Shh. How many degrees is east?
East would be 90 degrees.
90.
South would be
Finish it up.
south would be 180 or negative 180, and west would be negative 90. But then
180.
okay,
So what does that make west? West is 360?
No, it's 90.
That's only 3/4 of the way through the 270.
Oh.
270. And north is back at 360. Everybody cool? Now, the reason we don't have positive and negative, Jer, when we're doing the horizontal one is because then that gives us a direction, doesn't it? What your positive is different from my positive. Right? So we keep it all the way around. Cool? Okay, now, if I tell you that I am going to walk in a certain direction, where on this compass would I start from? Talk to your neighbor, figure it out. Right in the middle? Everybody's happy with that? So I'm going to start right here, yes? Now we're going to draw 4 lines. The first line we're going to draw, I am going to walk at a direction of 39 degrees. Which general direction is 39 degrees? Northeast, yes? Is it exactly northeast? Why not? Because 45 would be exactly northeast, right? From where do we begin counting? From north. And I'm going how far? 39 degrees. So here is my walking direction, yes? Where is the 39? Between north and where I walked. Yes? 39 degrees. I need to stop there and make sure everybody understands why that's the 39. Is everybody cool? Yeah? Okay. Can I do trigonometry right now? What's missing? What? I need another side, don't I? I need a triangle, yes? So, if I put this triangle, can I do trig? If I knew this distance and this distance, I could do trig, yes? Okay. What if I put in this triangle? Can I do trig? Of course I can. Why? No, it's not the exact same thing. Talk to your neighbor. Tell me how I could do trig on the blue triangle. Just wait a sec, Murad. I got you. You're right here at the top of the list. I want to let everybody talk.
There's no like. Get whatever's left, and that's the height there.
Now, there are two ways you can solve this. Murad, do you have one of them? You know which angle? Wait, let me draw them so it will be helpful. Do you know the yellow angle, the blue angle, or the green angle? Or do you know all three? What's the green angle? Green one's 90. Of course you know all of them. So which one do you know? Which one did you want to do first, Marat? The blue one. How big is the blue angle? 90 minus 39. Why? Because all the way to east is 90. But I've used 39 of them there. So what's left over? Go to your calculators. 41. 41? 51. Everybody agree? That is one way you could have done it. You also could have done something else. If this is 39, then this must be 39. Because that's the angle of depression and the angle of elevation if I turn it sideways, isn't it? Right? Is everybody cool with that? So even though I said I walked away on a heading of 39 degrees, now that you know trig, you could tell me how far I walked. Yes? Is everybody cool with that? Okay, we're going to draw 4 more lines. We're going to draw a green line at 117 degrees. I'm going to draw a gray line at 215 degrees. And I'm going to draw an orange line at 312 degrees. You guys don't have 3 colors, so you're just going to draw 3 more lines. Then I want you to set those lines up so we could do trig like we did in this quadrant. Is everybody cool? You're going to have 4 lines that look like this. Do as much of what I asked you to do as you think you can, because it's a little bit tricky. Okay? Do whatever you think you can. Talk to your neighbor, speak aloud, look at here, do whatever you need to do. So I got my green ink out. What general direction is the green line going to go? Southeast, right? So it's going to go somewhere down here. Does it matter exactly where I put it? No, of course not. Where do we start counting from? Okay, in math, where do we start counting from? No. In math, forget about directions. Where do we count from in math? 0. If it happens once in math, how many times does it happen? Always. So I must start counting at 0, yes? So if you want to, you can. So this is 117. Agreed? Can I do trig on that? I can't. I haven't taught you how to do trig for 117 degrees, have I? What is the maximum amount of degrees I've taught you guys to do trig? 90. So I need to make my 90-degree triangles, yes? So there's my trig triangles. To do trig on that, I need this theta, don't I? How big is it? The whole thing was 117. How much is that part of it? 90. So how much is left over for that? 27 degrees. Which automatically makes this what? 27 degrees. Which makes this what? How far is it from east to south? 90. How much of this did I use? So what's this? 63? Be strong, Joseph. Don't say 63. Say 63. because you can subtract.
Okay.
Is everybody cool? Does everybody understand? If you were on a scale of 1 to 10, are you at least at a 3?
Yeah.
All right, good, because we're doing 2 more of these. So if you're at 3 now, after the next one you should be at 6, and after the next one you should be at 9, right? Yeah. Next color was gray. Where is that line going to be? In general direction. Southwest. Down here, yes? From where do I start counting? 0. So all the way around is 215, yes? Can I do trig there yet? Now can I do trig? All the way is 215. What's that? How far is it to south? 180. But I've gone 215. So what's that? 35. What does that automatically make this? 35. What does that make this? 90 minus 35. 55. And what does that automatically make this? 55. Is everybody cool? Sweet. Are we at a 6? Nice. No, the speaker does not go to 11. I've seen Spinal Tap too.
This one is going to go to 11. I don't know. This goes to 11.
Okay. So, 312. What direction am I going? Northwest. Going to come out here. All the way around is how far? 312. Can I do trig yet? Can I do trig now? What is that? 42. Why? 312 minus 270 is 42 degrees. What does that make this automatically? 42. What does that make this? 48. What does that make this automatically? 48. Is everybody cool? Everybody. Sweet. Now that you understand that, there's another way that we do directions. It's based on this. So make another compass. Make it north, east, south, west. And this is the other way we do directions. The other way we do directions looks like this. It is a starting direction, a start, an adjustment, and then a direction. So what that means is I'm given a way I'm starting to go. I am adjusting that way in another direction. The adjustment is always an amount of degrees. Okay? Everybody cool? Once, twice, thrice? All right. So if I told you that I was going to walk north, and I'm going to use a light blue for that, where do I start? Right in the middle. And where would I walk? Straight up. Agreed? Okay. But I am not walking north. I am walking north, and I am adjusting 28, so 28 degrees, to the west. So if there was no adjustment, I would be going straight north, yes? But I'm adjusting 28 degrees in which direction? Where is west? Left. So I'm adjusting 28 degrees towards the west. Can I do trig? I erased my north-south. It disappeared. Where's the 28? Between west and blue or north and blue? North and blue. Because I adjusted 28 degrees towards the west. Can't do trig yet. Now I can. What's this? What is it? 62. What is this? 28. What is this? 62. Now, knowing what you know, I walked north 28 west. Joseph started walking west. But I want to walk with Joseph. If Joseph started west, how do you finish his direction so we walk the same path? Moret. West 62 north. Does everybody understand? Okay, we're going to draw 3 more lines to get us up to at least a 9, yes? The first one you are going to draw is north 65 east. And then I want you to draw its other direction. You're going to give me that. Everybody cool? That's the first one you're going to try. If you get that one, I want you to do south 72 east. And then give me the other direction. And then lastly, we'll do west 15 south. I shouldn't have used green again. Something that contrasts nicely with green. I've already used light. Let's get pink into the party. What did I say? West 15 south, yes? Take a moment. Try it out. See you later, Mr. Como. Have a good Thanksgiving.
Yes, you too.
Thank you.
No leftovers.
Not in my house. That's why I can only play hockey for 60 minutes.
Oh.
No leftovers.
Why did you come here and sit here?
Because Mr. Como is a good leader. And shouldn't a leader know how his troops perform?
So if like right now we were like performing badly, that would show him that like
It would show him nothing because he wasn't officially doing it, but he would know in his head. Kind of like when I walk around and check your homework. Does it affect your grade? Do I put it anywhere official? But do I know in my head that you haven't been doing your work? So when you come to me and complain, right? And Mr. Como's daughter is in grade 10.
Really?
Yes.
what's your name?
I don't know, not at this school.
Oh.
So, grade 10 math is something that a lot of grown-ups need a refresher on. All right, we all cool? There's the 65, there's 65, so what's this? 25, and what's this?
25.
Cool?
Yep.
What is the other version of this?
East 25.
East 25 north. Now let's do the green one. South 72 east. 72. Make your trig triangles. What's this? 18. What's this? 18. What's this?
72.
And what's the other way to write that?
East.
East 18 south. Now, use your brains. Which of those, the blue or the green, do you think is the better one?
East 18 south. Well, no, 'cause
They get you to the exact same place. One of them is considered correct. Which one, Joseph?
The one that comes from straight up and down because I'd like south 72 east.
So you like the blue one?
Yes.
Okay. Everybody agree? Nobody likes the green one? Josh likes the green one. Why do you like the green one? And don't say it's because you're making a big deal out of this, Myers. Why do you like the green one?
The bottom one. East.
It's going the right way. The 18 isn't past 45, is it? Everybody with me? Once we go past 45, we should change to the other one because it's like rounding up, isn't it? Everybody cool?
Yeah.
All right. And then the pink one. Pink one will come out west, but 15 degrees south. 15. So what's this? 75. What's this? 75. What's this? 15. And how do I change it?
It would be
South 75 west.
70.
Everybody cool? All right. Now that, ladies and gentlemen, are all the tools you need to solve problems with this. Who is somebody in the real world that might need to solve these problems? A geographer. Well, we're not really exploring anymore, but we are mapping stuff, right? There's places on the planet where there's not a lot of people. Somebody had to make Google Maps, right? So that, where else? Engineering? Okay. What do you mean? What would you have to engineer that would require directions that is happening in our part of the world right now? Oil pipelines. Who else might need this? Pardon me? Architects. Who else? Pilots. Search and rescue. Where was the boat last? There. What direction was it going? That way. Right? Everybody cool? Lots of real life use for this, yeah? Now, I don't want you to do what I'm about to do. I want you to pay undivided attention and think about it. You can talk with your neighbor about it, okay? Because what you have been given will allow you to solve the problem I'm about to ask of you. Okay? That's supposed to say he. Yeah. Are there directions involved? So what would be my first thing I would need to do if I was you, a student? Draw them. So you don't need to draw them because we're just thinking. Where on that do I start walking? Right in the center. How far do I walk? 25 kilometers in what direction? 32 degrees. So out this way, yes? And I walked 25K, yes? Where's the 32? Between black, north and blue, or east and blue? North and blue. There's 32, yes? So what is this in here? 58. 58. Is everybody cool? All right. Now, what did I do at the end of 25K? I turned, which means I'm starting in a new direction, aren't I? So what must I draw? Another compass. Yes? Now, if I didn't turn, the line would go this way, yes? But I did turn. How far? 85 degrees to the south, yes? So if this line continued on, what direction is south from that blue line? It's down, yes? And how far did I go? 85 degrees. So my new walk is going to be 85 degrees away from here. Down there, yes? And we know that I stopped directly east of home, right? Okay. So, where is the 85? Between the blue and yellow? On the top or on the bottom? On the top. That's 85, correct? What is all of that? 180, right? I used 85 of it. So what is this? 95. Does everyone agree? Yeah? Okay. So now I'm done with this compass, right? So I'm going to go ahead and erase it. And I know that this is 95. Yeah? Everybody cool? And I know that I ended up over here, right? How many degrees are in a triangle? 180. I've used 95 there. I've used 58 there. Yes? So can I find out the third angle? By doing what? Add and subtract from 180, right? So what is it? No. 27. Is everybody cool? Is everyone cool? Now, does that give me a triangle? At your level of trig, can you do trig with this right now? No, why? No what? No right angles. So what would you have to do? Make a right angle. Where? Right down the middle. Right? Now, that gives me this red triangle, yes? Do I have a theta in the red triangle? What is it? 58. What else do I have in the red triangle? I got 25, which is hypotenuse, yes? Hypotenuse equals 25, right? What do I need? I need this leg, right? Which is what? It's adjacent. So my adjacent would equal x, correct? Now the only trig you people have done uses O and A, right? Right? Well, I've got A and H. But I've got a right angle triangle. Can I do trig with a right angle triangle? I can. Can you yet? No. But you understand A's and H's, don't you? If you could find this, could you use those two numbers to find this? Yes, you could, couldn't you? You would Pythagoras for here, right? The reason I'm not getting you to write this down is because I haven't actually taught you this yet. I'm showing you how you could get somewhere if you had this last tool. Everybody with me? Now, if I have this side from doing Pythagoras, over here, do I have a theta? What is it? 27. Do I have this side? If I knew how, I would have it, wouldn't I? What would that be? Opposite or adjacent? Opposite I'd use my red Pythagoras, yes? Okay. And then what do I need in this triangle? I would need that, yeah? Which would be what? Adjacent, right? To my theta. What uses O and A? Which trig that you know? Tan, right? So on the blue side, it would be tan of 27 would be opposite my red Pythagoras answer divided by what? This that I do not know, correct? So I'm going to call it y because I've already used an x. Right? And then I know how to trig that, don't I? It would be red Pythagoras divided by tan 27. And then what would I do with y and x to find out how far I would have to walk? Add them. So all of you followed that, yes? The only thing that made you stumble was you don't have this tool, do you? But you know that trig shows relationships in triangles, yes? And you know that we have a tool to deal with the legs. And you know that the legs and the hypotenuse are related, yes? So there must be a trig that deals with the hypotenuse. That's what we're going to do today. Everybody cool? How? Just going to leave it at that. We already know one ratio. Tan is what? We're on 58 now. What is tan? Opposite leg over adjacent leg. What's missing? The hypotenuse. We haven't talked about the hypotenuse. The only thing we know about the hypotenuse is Pythagoras, yes? All right. So, you read that right there, and while you're reading, you see, all right, I already know what tangent is. Oh, two new names. Sine and cosine. Look at your calculator by tan. What do you see? Sin and cos. Everybody cool? All right. Sine compares the opposite leg to the hypotenuse. You're smart people. If sine does the opposite, what does cosine do? Adjacent to the hypotenuse. Everybody cool? All right. Now we know three things. This is a fake word. It doesn't mean anything. It's just to remind you that the sine is the opposite divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse. And the tangent is the opposite divided by the adjacent. Okay? Will I ask you to memorize that? Nope. Have I asked you to memorize any other formulas? Nope. It's on your formula sheet. Will your life be easier if you memorize it? Of course it will. Now, what does that much white space mean in my world? We're going to draw something there. What do I need to draw to do trig? A triangle. We are not going to draw the triangle that you're used to seeing. We are not drawing that triangle. That's for babies. We're going to draw a grown-up triangle.
Oh, wait, what?
Still a right angle, but it's in a different spot than you're used to seeing, yes? Everybody cool? All right. I'm going to label the angles. When I label the angles, what kind of letter will I use? Capital letters. Excellent. I'm going to use, I want to do this sensibly. A, B, and Q. I'm choosing Q on purpose because now I want you to label the sides. What do we label the sides with? Lowercase. So where is little a? Right, left, or bottom? Right. Little a. Where is little q? Left. And where is little b? Bottom. Now, knowing what you know up here, tell me what the sign of big Q is. Sine is opposite divided by hypotenuse. What is opposite of big Q? Lil Q. What is the hypotenuse? Lil B, because he's opposite the 90. What is the cos of big Q? A over lil b. Adjacent over hypotenuse. Cosine. What is the tan of big Q? It's not 6. Q over lil a. Opposite and adjacent for tan. How do you know what's opposite and adjacent? That is where you are standing. Since I'm dealing with Q, I was right there. So that is opposite, that is adjacent, that is hypotenuse. Now, you're intelligent young people. If we did the sine, cos, and tan of Q, what is the next angle we're going to do? Yeah. Sine of A is what? Cos of A is what? And tan of A is what? Fill them in. Now, I am no longer sitting by Q. Now I am over here. So what is the sine of A? A over B. What is the cos of A? Q over B. What is the tan of A? It's supposed to be green. A over Q. What do you notice? The sine of one of the angles is the cos of the other one. And the tangents are reciprocals. Now, when we did our tan questions with trig, we followed a certain method of doing it, yes? What was the first thing we did? What was the first thing I asked you with all the millions of tan questions we've done? Do I have a theta? So, is this still trig? If it happens once in math, how often does it happen? Every time. So what's the first question I'm going to ask you? Is there a theta? Is there a theta? Tobby, yeah, go. Oh, what?
How do you know which one the adjacent is? Because there's two sides.
Well, I just, that was why I drew myself here. What does opposite mean? Across. So there's opposite. Adjacent is, it's the adjacent leg, right? There's two lines left in this triangle. Which one of them is a leg? B or Q? Which is a leg? That's how you know what adjacent is. It's the one that's beside you. That's a leg. Everybody cool? Great. So what is the first question I'm asking you with that first triangle? No, the first question I'm going to ask you. Is there a what? Theta. Is there? What is it? 12. Theta equals 12. Which means, where on this triangle do I draw my smiling face?
At the bottom, like the bottom.
Right by the 12, because that's the angle I care about. Now that I'm there, I can decide what is opposite and adjacent, yes? What do I have? What is that? Opposite. So what opposite equals x? What else do I have? I do not. I do not. No, I do not. I have a hypotenuse. Of what? 25. What uses O and H? Sine. Now, when we were doing O and A, it was tan. Now, it is sine theta equals O over H. Fill in what you know. Sine, what's theta? 12 equals, what's O? X over what? 25. Now when we're doing tangent, it's 25 times tan, right? We're not doing tangent now, but are we doing the same math? Yeah, so what do I hit instead? 25 sine 12 will get me X. And what is the answer?
5.2.
Do I need to check your rounding?
It was 5.19.
Excellent. Is everybody cool? All right. What is the first question I'm going to ask you about the second triangle? Do you have a theta? Do you?
Yes.
What is it? 19. Once you have decided on your theta, where do you send my smiling pink face? To the 12, or to the 19. Once I am set up there, now I have my opposites and adjacents. What is that 40 compared to me? Adjacent is 40. What is the other side of which I am concerned? The hypotenuse, which is what? X. What uses A and H? Cosine. Cos theta is A over H. What's theta? Theta is 19. What's A? 40 over what's H? X. When the number's on top, what do I do? It was 40 divided by tan, right? But we're not doing tan, so we're just changing the button we hit, but we're doing the same math. So it's what? 40 divided by cos 19. And what is that?
42.3.
42.3. Does that answer make sense? One of the legs of the triangle is 40. We only moved a tiny bit, 19 degrees, so this has to be very short. So the hypotenuse must be a little bit more than 40. Was it? Booyah, Grandma. And lastly, do I have a theta? It is X. Once I have decided where theta is, where does my smiling face slide? To theta. Why must I move there? So I know what the O and the A is, because it's from my point of view. What do I have? I have an adjacent of 13 and an hypotenuse of 22. What uses A and H? Cosine theta is A over H. Now, what's theta? Cos X. I don't know the angle. When I didn't know the angle and it was tan, what did I do? Shift tan. When I don't know the angle and it's cos, what do you think I do? Shift cos. Of what? 13 over 22. And what do I get for an angle? What? So 54, because we round angles to the nearest degree. Is there anything mathematically different about sine, cos, and tan? No. The difference is which sides of the triangle you use. That's the only new thing. Do you all understand O, A, and H? So there is no reason to not be able to do trig, is there? Is there? No. Your job for your 3-day-long weekend is to do only page 59. And you have the answers. I am warning you right now. There is a typo in the answers. So, if you find you have done the work and you've looked in your notes and you know you did it right, rest easy. I'm not going to tell you where the typo is to see if it fools you. Okay? Good. Now you also have 10 minutes left in class, which you could use to work. Class goes till 11.